Hi, everyone. Thanks for joining me to talk about kind of next generation smart contracts and oracles and how that all fits together. So I think the useful thing to do at most of these presentations is just get some shared context so we know the problem we're talking about and the different kind of issues with solving that problem and how to look at that. So the fundamental problem is that all these blockchain environments where we build these highly reliable contracts that are going to change the way people do commerce and they're going to create new trust relationships, those environments can't speak with external systems. Due to the way that mining occurs around the blocks and their transactions, there's actually no secure way to get the same miner set that you have to acquire external data. This creates something known as the oracle problem or the smart contract connectivity problem. And what this effectively means is that you can write a contract about data in a chain, which is basically token data, ledger data, which natively lives in that environment, but you can't write a contract about any external event. So this excludes market events, IoT events. It excludes an entire world of events. You also can't generate events from contracts. And this is, in our opinion, what has kept contracts limited to only token movement, right? So the idea that contracts would continue to be limited to only token movement is a problematic idea for us, not because token movement is a bad thing, it's a good thing. It's only a small percentage of what we think all of this can actually do. Moving around tokenized assets and keeping that data natively on the same ledger where the logic lives is a great thing, and it's created, a lot of great opportunities, and it's going to continue to create all kinds of good ownership and trust relationships with people. But the reality is that if you look at the digital world that the blockchain world is trying to kind of eat up and replace, you see that the majority of contracts are not about mere data ownership or ownership movement, they're about events. So that the majority of contracts, digital contracts out in the world, are about market events or IoT events or advertising events, or it's all very events based. Now, if we solve this problem, I think just to put it in historical context, I think what this will look is it'll look like a step function in the value that and the usefulness that people can provide with these systems. I mean, we've seen a few step functions like this before, where basically in the 13th, 14th time frame, we went from Bitcoin multi-sig as the only smart contract at all to some version of other smart contracts in the form of these protocol contracts, these opcode-based contracts in 13 and 14, where you had to spend 6 months talking to protocol developers to make a new opcode for you to build a contract. Now, what Ethereum did, and what they deserve a lot of their success for, is for taking our space from this very difficult model of let's have a protocol developer add an opcode, and that adding of an opcode will allow us to write our contract, which is a 6-month to 1-year process, which at the rate our space moves basically means by the time you're done, you're 6 months behind. So with Ethereum, they took that from 6 months to a year. They took it down to a few days to a couple of weeks to code up your contract. The next kind of incremental increase in features and therefore the value that can be provided with those features, we think, is the ability to have these scriptable contracts be scripted around events, both the intake of external data and the output of various important events. Probably some of the most important events for financial contracts, like the types that we all work on, are payment events. So we think the next kind of step function in value, just like Ethereum took us from this broken opcode model where it took months to get a contract written at all, it took us from that to this scriptable model where you could write a contract in days. And we think the next step is going from a scriptable model where all you can write a contract in days about is tokens to one where in that same amount of time, in those same collection of days, you could now write an events-driven contract. Now, this is basically the problem that we work on, so we have a good amount of experience with it. We focus exclusively on solving this oracle problem, smart connectivity problem, creating this abstraction layer between blockchains and data events and output events and kind of the computations they need to do outside of the chain. This extends to data inputs, all kinds of enterprise event outputs or payment outputs, and a certain amount of cross-chain connectivity probably at some point later on. The thing that we've kind of learned from doing this for a number of years, I mean, we've been building smart contracts, I think, for about approaching 6 years now, and we've been doing oracles for a large number of years, during that time. I think what we've learned is what we're effectively doing when we're building an events-driven contract or a connected contract is we're expanding the definition. So the usual definition of a contract is this thing in the middle where you have the state, and because that state relates to data in the same environment as the logic and the state change itself, we've just encapsulated the idea of a smart contract as code that runs in an environment like Ethereum or the Polkadot network or any of these other environments. But the reality is, if we make an events-driven contract, if we make a connected contract, how we define it pretty much needs to expand, because we want to retain the definition of security, right? We want to maintain the idea that this is a highly reliable mechanism, but we also want to expand its features. So that expansion in features creates surface area, and it creates surface area. So we want those features. That creates the surface area of I now have more systems to secure if I want to maintain this reliability that I'm promising people as a defining characteristic, or probably the defining characteristic of the system. And now I need to generate this security end to end. So basically the goal of our body of work is to make it so that you can, just like you can basically in the function as a service model give contract code over to Ethereum or Polkadot or one of these networks, you should be able to give over this oracle problem or these triggering events or even some amount of off-chain computation to basically a layer 2 system that's responsible for making sure the end-to-end security of the contract is maintained. Because if you don't do that, the defining quality, the reliability quality disappears. And then it's no better than centralized systems. So that's what, I think that's the dynamic that all the kind of technologists and architect folks, that's the dynamic they seek to avoid while still creating value, right? While still making something useful. So just to give an overview of the approach that we've taken to this and how we look at approaching the solution to this problem, at the core of it is decentralization, is the idea that you can decentralize the oracle mechanism just like the computation is decentralized. We feel very strongly there's a need for a binding commitment between an oracle and a contract, such that that oracle commits to very specific outcomes for that contract's correct operation, and it makes that commitment on chain and binding, and it provides stake and crypto economic guarantees behind the fulfillment of that commitment. Because if the entire contract depends on a single input, you really want that input to make sure it gets there. The next piece that we feel very strongly about is provable reliability. So what that means is that you have a lot of data where you could reasonably come to a conclusion about the security of a node. And if you can come to the security of a single node and you compose it into ensembles of nodes, then you can come to an idea about the security about an oracle network. So now you have decentralization and you have an informed view about why an oracle network of 3, 5, 7, 10, 15, 21, however many oracles you want to secure the value that they're triggering, you should have a good reason to believe that oracle network is secure. And those reasons are generated through data that we try to float up to the user. Another thing that we practice that really we think more people might want to consider practicing it in our space. It's a very logical idea from the traditional security and DevOps world. It's basically defense in depth. So it's the idea that you layer on multiple security approaches on top of each other, and that gives you greater overall security. I mean, it's not like a revelation, but it's one of these ideas that we think putting it in practice is something that we do our best to do, and we'd like to see more of. In our case, we do this with layering trusted execution environments on top of a decentralized network of nodes, and then we give people the option to select more secure environments as a property of their node. The other thing that, the final point that we think is very important is that this is all done in kind of open source, community-driven, security audited manner. Because what we're really, I think what we're really focused on doing is building a shared kind of global and shared public resource for people to solve this problem together. So this isn't as much about how does like just Chainlink solve this problem. It's more about how do you create a framework and how do you create a certain amount of assumptions about other people's ability to contribute to solving this problem. which means working on secure integration code, being a node operator with the right incentives, being a security auditor or security researcher that also has incentives to audit the integration code, the node's operation, the core code. And at that point, when we have kind of an open source, well, the people that need this, we've already seen them naturally contributing back to it. So part of the thing I think it's appropriate to look at in this presentation, in the spirit of kind of the Web3 Summit, which they've done a great job at putting together, by the way, is to look at how basically community participants can help build something like this for their own consumption and for the consumption of others, so we can all build these contracts. But before we get into that, I think it's just useful to look at exactly what's happening in the model. So at the core of the model, we want to avoid a very simple problem. It's the same problem that decentralized computation avoids. We just want to avoid it one level out from decentralized computation. It's the problem of you have a single node, right? So this is, our space has a lot of really nice words, but essentially decentralization is full replicas run by independent node operators coming to consensus about a computation. Here you have decentralized computation where they are coming to consensus in an independent full replica manner. But if you have a single closed source, some kind of service run somewhere, then it's not at all clear to us how in the security model of this space you would ever trust that single closed source service to trigger the value in this system that has entirely different security assumptions. So the first key problem to avoid is this centralization problem and the risk and all the dynamics we didn't want with this problem when we looked at how to do computation to begin with. Fundamentally speaking, it's a very relatively straightforward approach where you need a secure and provable way to create decentralization for the Oracle mechanism. The manner in which we approach creating that is basically this service agreement model where an Oracle contract receives a request from a user contract and then makes a commitment. So the key idea here is that you can have oracles make very specific commitments about, I will send you this data at this frequency, I won't deviate, this much from other node operators. I'll do it, this often for this time period, and I'm putting up a certain amount of stake to guarantee that I'll do that, right? So it's on a case-by-case basis definition of and an economic guarantee that the data your contract's relying on will be received. Once you're able to arrive at a certain level of decentralization at this second level out from the core computations kind of decentralization, once you're able to have this type of security at the essentially the middleware level, then you can have it at the data level. So then you can have multiple Oracle nodes, and then you can have multiple data providers if you want. This is once again about choice, and it's about developers being able to decide, right now I have $1 million in my market, I want 3 nodes. Tomorrow I have 10 million, I want 15 nodes. And I want this many number of data sources. So the goal for us is to create highly secure, also easily usable, the way Ethereum made it usable to make contracts, resource for people to build these events-driven next-generation contracts. Now, one thing that I found is always very illustrative is examples. This is essentially a decentralized derivative, so it's a decentralized finance product that instead of being triggered by one data feed through one node, which the attack vector there is relatively clear, you can have multiple node operators for multiple data sources acquiring data, triggering the contract, creating a level of security and reliability that you simply can't get with a single node operator and a single data source, no matter how much you want to trust or like that node operator or that data source. This is the fundamental kind of idea behind our model, and then, or our spaces model. And then you need to do payment. So oracles also enable a large amount of payment events, which in the case of the types of contracts we're working on is rather useful. So I think at this event, once again, it's probably appropriate to look at how can we all work together to make something like this happen. I'm already assuming we want this to happen. Clearly, I'm very biased, but assuming other people think the same way, how does something like this happen? And how does somebody consume this? How does somebody contribute to it? Things like that. So at the fundamental level, it kind of starts at the node operator level. And at the node operator level, what we seek to do is to give you a lot of clarity about what is a high-quality node operator. We're very lucky to have great ecosystem companies like Linkpool and Honeycomb and others that are building tools and services for people to discover and for people to generate all kinds of new nodes and inputs and things that other people can use to then build their contracts. So if you're a node operator, the dynamic is that you become part of this ecosystem and your data begins getting collected. There's a large and growing ecosystem of these node operators. I think we went to mainnet a few months ago. This launched a few weeks ago. I think on this specific marketplace, there's like 45 node operators listed now, and I think a quarter of them are security reviewed and identity reviewed, as far as I know. So the first way people participate is they can become node operators, and they can offer their services to quote-unquote mine inputs into these contracts. What they do when they mine inputs is they basically commit to perform a job. So they commit to perform a body of off-chain work, and that off-chain work is, in many initial cases, defined as data delivery. Basically, I need a highly secure mechanism to give me high-quality data, because my contract is predicated on the idea that it's highly secure, and so I need another mechanism to solve this problem for me. So right now, I think there's, at this point, hundreds of jobs available to folks to use. We're probably sometime soon going to be approaching thousands of jobs. These jobs are like individual pieces of work about, I want a specific piece of data, and these jobs are generated from something called adapters. So this is where basically any developer and many developers that are building dApps are already contributing. They can sit down and write the integration level code that takes the core security of Chainlink, which we've spent a lot of money on, a lot of time on with security auditors, and they can create an integration such that any contract that wants to use that data feed can easily now have access to it. These adapters are written right now by community members. A lot of times they give things back to the community, which in my experience is how open source works, and how we're at some point soon I think we're going to see more and more people using this, and more people putting back useful adapters into larger circulation, and then those adapters being security audited. So that you have a full end-to-end system that you can believe is secure, right? The only thing you probably won't know about is the data source, and then once the value secured by that data source becomes large enough, then they become compelled to become more open. But until then, that's not likely. But at the very least, what we can do is we can have full transparency and security at the contract execution level and at all the levels of what an Oracle does, right? This is one example. It's somebody coded up a Halo 5 adapter, so if you wanted to make some prediction market about an esports event, somebody who's probably working on a project related to this made this adapter, put it out there for other people to use, and I think really this is how a lot of this is supposed to and is going to work. Is that people are going, and this one's, for example, under the MIT license, and it's clearly stated there. I think it's the logical evolution that if we want a solution like this, we should all come together and in an open source kind of manner build one. Now, another example of people contributing to this is folks at Honeycomb. So what they're making is a collection of data feeds that can be used by node operators. And I think you're starting to see that there's a few places where folks can participate in creating security here, but the reality is that making adapters, running nodes, writing the contracts, kind of all of this eventually fits together in a way where the people making the adapters, the people running the nodes, have the right economic incentive from the point of view of all the people consuming these resources. And that's the dynamic that we really want to achieve. From our point of view, what we do in this process is we create a framework that allows all the transactions generated from this to create a large amount of highly secure data. That highly secure data is then floated to users. It's also augmented by all kinds of things like certification. initially from us and sometime soon from other security auditors and penetration testing firms. And this leads to dynamics like Sybil resistance, highly audited node operators, and a large amount of on-chain performance data that proves that node operators are secure. Eventually, with a high amount of high-quality data about node operators, you arrive at a web of trust model. This web of trust model is the same thing you see in PGP signing. So it's a fundamentally kind of logical model, where in this case, it's not proactive signing, it's usage. So essentially what happens is that usage by multiple sources is a signal of trust. And as the amount of usage increases for these oracles that continually provide greater and greater value through more integrations, you start to get a certain trust dynamic that this specific oracle is servicing so many other high-quality users that it is the resource that people want to rely on for this type of data. And that's based on the fundamental cryptographic ideas behind things like PGP and other similar systems. Yeah, there's a number of positive dynamics in this web of trust model, and by floating the data in this very secure manner, that's part of what we want to arrive at. Going forward, our focus for building this out is the creation of more off-chain jobs. You can think of jobs almost as off-chain functions that are very secure and are meant to be consumed by smart contracts specifically. We're going to be going live in many additional blockchain environments so that Oracle operators can service many environments, and that gives them, well, first it increases the overall security because you get more data about usage of those node operators, and secondly, it's very attractive to the node operators and the data providers because they can now service multiple environments, not just one environment. Servicing just one environment is not as attractive as servicing all the blockchain environments where people would want to consume your data or your service as a node operator. We're going to be continuing to improve the security dynamics around proving that a node operator is secure, and that means continually improving what we consider to be certification. And eventually, I think sometime soon there will be a competitive market. Well, I don't know if it'll be competitive, but there'll be a market for certifying node operators and doing audit on integration code, especially as those things get more usage. And another focus we have is providing increasingly stronger cryptoeconomic guarantees through staking and continually improving how those cryptoeconomic guarantees give the smart contract user a reason to believe that they will be receiving the data that their $100 million contract depends on. If we build all this, I think the exciting thing that can happen is somebody could build something like a crop insurance smart contract for the emerging market in a number of days. Like the place we want to arrive at is, people don't have certain types of contracts in certain geographies because the local legal system can't allow it. And what we really want is to enable people to build the types of contracts that they can't build today. But those contracts are going to be events-based, and they're going to be based on all these different inputs. And so our focus is going to be on making the building of a contract like this just as quick and easy as, or probably even easier than writing out a smart contract today. It shouldn't be a big burden for you to build all the inputs and outputs you need for something like this. It should be a one-day task that you can rely on the security of those inputs and outputs. Thank you very much for your attention. Unfortunately, I think I'm over time. There's other stuff about trusted execution environments which you can look into if you're interested. If you're interested in this problem, we're working on it basically day and night. We're pretty much fanatical at this point about this problem. If you're interested in it or you think you might be, feel free to talk to me. And thank you very much for your attention. Hopefully you guys find this useful.